Okay, so first off, it wants me to change each of these decimals into fractions and then add them up. Yeah, that's a good question. So what we're going for is trying to help you be more and more comfortable with decimals and fractions as you'll be a teacher. You want to be a master of decimals and fractions. Okay, so how do you take 9.5 and change that into a fraction? There's a lot of ways. Let's make it just one fraction. Let me just give you the game plan to make it easy. Basically, you're going to put it over whatever the name of the ending place is. This one ends in the what's place. What is that place? That's tenths, right? First place to the right of the decimal is the tenths place. So 95 over 10. Now, that could be reduced, but actually, don't. Oh, they're going to make me, huh? I think. Yeah, let me double check. I think they're going to make me. Because if I divide by 5, what's that going to be? 19. Yeah, so they're going to let you just leave it just like that. So the first one will be just 95 over 10. Even though that's reducible, we don't want to reduce because in a minute we're going to try to add. We want common denominators. So let's just leave it that way. Okay, the next one. 25.4. It's the same deal. It's whatever the name of the ending. Where does that one end? Same place, tenths place, huh? So you just write the entire number over the name of the place it ends. I don't know if you know you can just do it that way. It's 254 over 10. That is 25.4. You remember, right? When you divide by 10, it makes the decimal go back one place. You know what I mean? So 254 divided by 10, decimal go back one place, it would be 25.4, wouldn't it? So it's right. So does everybody see the game plan? Try it on the next one. 0.78. So 0.78. That 0 in the front is not doing anything. That's why I don't even say it. Just 0.78. So that's going to be 78 over. And how do you know what it goes over? The name of the ending place, huh? So this one ends in the what's place. That 8 is in the what's place. Hundredths, huh? Because the 7 is the tenths place. The 8 is the hundredths place. So that's 78 over 100. Everybody good there? So again, the denominator is always the ending place. So if it ends in the hundredths, denominator is 100. If it ends in the tenths, denominator is 10. And then you just put the entire number on the top with no decimal or anything. And that'll be the right fraction. That's actually true. Right, if you divide 78 by 100, decimal go back 2 places, right? 2 zeros goes back 2 places. It's right, huh? Okay, so those are those 3 answers. Now, they want me to add these fractions together. So, how am I going to add these fractions? Add the fractions and write your answer in decimal form. Add them up and write your answer in decimal form. Okay. So how am I going to add those 3 fractions? Well, to add fractions, they have to have what? To add or subtract fractions, the denominators have to be the same, don't they? Common denominator. So I've got to make all 3 of those. If I want to add those, they can have the same denominator. So 2 of them have 10, 1 of them has 100. What am I going to do? Make them all 100, huh? Right? So you just go to the first one and just multiply top and bottom of him by 10. He'll become 950 over 100. Take the second one, right? Because I'm doing top and bottom. I'm not changing anything. Just changing the way it looks, but not the value. Next one will be 2540 over 100. And the third one is already good. It's already got the denominator of 100. So now we can add them up, can't we? Now we can go 950, 2540, and 78. Add them all up. We good there? Just add them all up. 8, just adding vertically here. 8 to 11, 16, 10, 15. 1 and 2 is 3. Good to there so far. 3, 5, 6, 8. I just added them up. And they all have common denominator, right? I made all 3 denominators the same. Made all 3 denominators 100. So then I can just add them up, which I just added up the numerators, the tops. Now, so that's the answer for the top. And what's the bottom? What's the denom? Yeah, it's 100, because remember we made them all have a denominator of 100, huh? So it's 3, 5, 6, 8 over 100, right? They all had 100, 100, 100 denominator. We made common denominator. So now, they asked me to change answer in decimal form. So how do I change that to a decimal now? 3568 over 100. What happens to a number when you divide by 100? The decimal. Where's the decimal right now? I don't see a decimal. Where is it right now? Yeah, it's like a period in a sentence. So if somebody forgets to put the period on, you know where it is. It's at the end. Same thing for decimal. If there's no decimal showing, it's always at the end. But then divide by 100, that decimal will go boom, boom, right? 2 zeros, 2 places when you divide. Remember, if you multiply by 10 or 100, it goes to the right. It gets bigger, huh? If you divide, it goes left. So that'd be 35.68. 35.68. Now, why in the world did they have me go through all that? They want you, remember, they want to make you a master of decimals. Not just one who sort of knows some rules and can follow them, but really a person who knows decimals, fractions deeply, understands really why the rules are what they are, and kind of like deeply place value now because you had to do it in more difficult setting. Think about what you would teach kids to do to add decimals. Let's just do normal decimal adding. What would you tell them? You'd say, okay, kids, line up the decimals, huh? And that's the rule. That's real good. 9.5, 25.4, 0.78. Right? Isn't that how we would line up the decimals when we add them? That's totally correct. Well, look at what we did here. See how they're lined up the same? The decimal's really right here. I didn't show it. It's right there. See how they're lined up just right? So what if a child asked you, why do we line up the decimals? Well, you see why it's true? Because that's the same thing as getting a common denominator, isn't it? Lining up the place values is the same thing as making the denominators the same. See how the process comes out the same when we made them all 100? But then in the end, we just moved the decimal back 2 places. See, it did end up right here, didn't it? Because we divided by 100. It's the same thing. That's why that rule is true in decimals. That's why lining up decimals is right, because these are each fractions, really, who have, if you line up the decimals, it's like making the denominators 6. It's way easier, isn't it? Decimals are way easier. But it's the same idea. It's the same idea as common denominator. That's what it is. It's the same thing. So they're just emphasizing that to you. They're just showing you how those connect and are really the same thing. Okay, I want to multiply those 2 decimals. Do you remember just the rules, just the plain simple rules? How do you multiply 2 decimal numbers by hand? What's the rule there? What do you do? So 5 times 9 is 45. So I just do that first off, right? 5 times 9 is 45. And then what do I do? Where's the decimal go? How do you know where the decimal goes? Anybody remember? Might be a while since you did this by hand, huh? Yeah, how'd you know? You count total places. Yeah, remember? So you don't line them up, huh? It isn't like adding, subtracting. You with me? If I was to add, well, let me finish before I do something else. Sorry. 1 place back, 2 places back. Exactly. Good job. And then you go 1, 2 places back, right? You count total places for multiplying decimals. Exactly right. Yeah, which is different than adding, subtracting. If I was adding these or subtracting them, I would just line them up and that'd be 1.4. I wouldn't count places or anything, huh? So for adding, subtracting, let me just write that. For adding, subtracting decimals, we know the rule is line up the decimals. For multiplying decimals, you count spots. Oh, well, that's not very, it sounds like you're counting the spots on the Dalmatian. Let me be a little more clear. You count decimal places. Well, I don't know how to say this in a winsome way here. The answer, no. The total number of decimal places in the answer equals the other two added. Right? You add them up. You just go 1 place, 2 place. Right? 1 place, 2 place, 1, 2. So that's how we place the decimal when we're multiplying. But as one who will become a teacher of this, you don't want to just know that rule. You always want to be far above those you're teaching just so you can be helpful to them. And so the way to be helpful is to go, why? Why? Why is that true? Not just that's the rule, but why is that rule really true? Well, and something else would be false. Why? Why is that true? Well, that's what they're trying to show you on this problem. They're saying, well, think about this. What if you took the 0.9 and you made it a fraction, and the 0.5 and you made it a fraction, and then multiply those fractions, and notice what happens. Let's do it. So how do I make 0.9, that decimal, into a fraction? What's 0.9 as a fraction? 9/10. Good. Again, you just put the number over the ending place, huh? It ends 1 place to the right, 1 0 on the bottom, 10. And 0.5? 5/10. So we're not going to reduce them or anything because that's part of the whole thing. We want to see them as they are. So now you're going to multiply those 9/10 times 5/10. Right? We'll multiply them as fractions and see the decimal truth. So what do? How do you multiply two fractions? You just do it, huh? Just straight and straight, right? 5 times 9 is 45. 10 times 10 is 100. Now, if I want to change that back to decimal, what do? 2 zeros on the bottom, 2 places. Do you see why it is now? It's because the fraction numbers on the bottom are multiplying. And so, however many zeros for this guy, however many zeros for that guy, it's going to be total zeros there, total places back, huh? That's why that rule is true for decimals. Good. So let's try. We good on that? That making sense? Trying to see the rules from different angles. So I want to make 205. Make that into a fraction. How do you write 205 as a fraction? It's kind of weird. Any ideas? Yeah, just put it over 1. Well said. Just 205 over 1 is all we do on that. That's right. 205 over 1. And that still fits our rule, doesn't it? Because 205 ends in the what's place. That's the ones place, isn't it? So it always works to just put it over the name of the place it ends in. So, okay. Now, 0.03, that's 3 over 100. 2 places, 2 decimal places to the right, 2 zeros on the bottom. All right, now let's multiply them. 205 over 1 times 3 over 100. It's going to be 3 times 205. 3 times 2 is 6. 3 times 5 is 15. 1 times 100 is 100. And then how do you change that back to a decimal? Two places. 6.15, huh? Yeah, 6.15 is the decimal answer. Yeah, and what would you teach kids to do if they were multiplying 205 times 0.03? Let's just do the decimal rule as we just did with fractions. You would just say, look, just multiply the 3, huh? 3 times 5 is 15. 3 times 0 is 0. Add 1 is 1. 3 times 2 is 6. And the decimal, you count them 1, 2 places back, 1, 2. Now we see why it's 2. Because of that 100 on the bottom, huh? That's why it's 2 places back. Good? I think we've got it. I'm going to skip C. That's okay. Okay, so here we have, what is that, 827.21. See the decimal? Make it a little bigger. 0.21 there. Right like that. And times 5. So, what do you think? Where do you think the decimal goes? What I would encourage you to do is just think about 5 times about 800. Just estimate. But we're multiplying 5 times a number that's about 800. So if you did 800 times 5, it'd be 5 times 0, 5 times 0, and 5 times 8? 40. So it's about 4,000, isn't it? So the decimal needs to be right after the 6, doesn't it? So the number's about 4,000. We good? 4136.05. That's where the decimal must go. Oh, yeah, actually, I didn't need to do all that, did I? I could have just done the count rule, huh? Sorry, I was making up new rules. Well, they said estimate. Anyway, whatever. 1, 2 spots back. 1, 2. That was easier than all my multiply stuff. Yeah. You guys were giving me that look like, Mr. Heron, there's an easier way. I could tell. You were right. How about part B? Just count places, huh? 1, 2, 3 back. 1, 2, 3 back. Right there. So it's going to be 19888.042. Just count the decimal spots. We good? Total number of spots back. Now, part C is a little more tricky. Part C, we're going to have to estimate more. Are you guys comfortable with estimation? They mean take this number and say, look, it's about 128 over about 2. Just go to whole numbers. So this would be something that would be on that no calculator part that you actually get a calculator, you can just hit the buttons. But are you comfortable with numbers? So you can just make that 2. That's like 120, just round to the nearest whole number. And then 128 divided by 2, that's just cutting it in half, huh? So half of 12, 6, and half of 8, 4. It's about 64. So wait a minute, would they have 7, 2, 1? Right. So a number, what's closest, where would I put the decimal to make it like 64? 72.1, huh? That's close to 64. I was just estimating. Wouldn't be back here, 720. That's not close to 64, right? Wouldn't be right here. 7.21 is not close to 64. 72 is close to 64. Does that make sense? Hey, does anybody want to figure out a tricky rule for... Because can't we just do the decimal count thing that we were doing before?
Yeah.
Can we do that?
Yeah, you subtract the 2.
Good job. Good job, Carissa, right? Good observation. Yeah, basically, look up here. Carissa's right. When you're multiplying two numbers, you count them. 1, 2 back, 3 back, 1, 2, 3, right? But what about when you divide a number? See how this number is being divided? So here we're taking, it's 3 places back. Then dividing always has the opposite effect of multiplying, doesn't it? So it's going to undo it by 2 places. Decimal will end up 1 from the end. Sure enough, 1 from the end. See that? Anyway, there's always patterns in everything in math. That kind of stuff is good to point out to kids because that's really what for those that are going to go on and do science or math or engineering or something, you want to help them to start to look that way at things because that's the way a scientist thinks. That's the way an engineer thinks. They look for patterns in things. That's what you want to help them learn to do for those goals. Okay, so how do we do it? How do we convert 200 cubic inches to cubic centimeters? You guys done much converting? Do a little bit of converting here. There are moments that remain. Here's what to do. Start off with what they gave you, 200 cubic inches, right? And put over here your goal, what you want in the end. You want cubic centimeters. So I'm going to give you the game plan I learned by taking chemistry. Have you taken chemistry yet? Chemistry 3A or whatever it is. Or I don't know if you have to. Take that or... Anyway, that's where I learned to convert units. It wasn't a math class. It was chemistry. And I totally didn't understand it on the first exam. And I did them all like a really long, painful way. And then right after the first exam was over, Mr. McCallum, I remember, went up to the board and showed it again. And I was like, oh, now I get it. It was after the exam. It was so easy once I did this totally hard, crazy thing. Anyway, this is easy once you get it. So what you do is this is over 1, make it look like a fraction. It doesn't have a denominator, just put it over 1. You basically multiply by whatever will get rid of the thing you don't want. So in other words, right now I'm in cubic inches, huh? I don't want cubic inches. So, okay, I want to get rid of cubic inches. So what does that mean? You got to put them down here. Do you know units cross-cancel just like numbers do? That was what was news to me in chemistry. So you can put inches down here, cubic inches, and they'll cancel out. And you'll be rid of them, which is good. I don't want them anymore. I want to go in. And what do you want? And put on the top where you want to go. Where do I want to go? Cubic centimeters, huh? So notice no numbers yet. No numbers. That's the other part that was totally confusing for me. I didn't get that. When Mr. McCall was first teaching it, I was always putting down the numbers first. I didn't get it. You put down the units first, and you let them guide your numbers. I was working way too hard. You just say, look, I have cubic inches. I want them to cross cancel. So put them down there. Bye-bye. And cubic centimeters is what I want in the end. So put them on the top. Okay, then put down the numbers afterwards. Now, what numbers? Well, the numbers they gave me right here. They're telling you, right? Now, let's get rid of the cubic thing. We'll come back to it. Let's put in 2.54 regular centimeters. So where's that going to go? Next to centimeters is 1 regular inch. See, I didn't think hard. And now, cubic, because we need cubic. And that's it. We're out of time. But take your calculator, 200 times 2.54 cubed, and you'll have your answer. We'll go over that again next